this is Module 3, Lesson 2. We're going to continue with the idea of equivalent expressions. So the opening exercise says each envelope contains a number of triangles and a number of quadrilaterals. For this exercise, we're going to let T represent the number of triangles and Q represent the number of quadrilaterals. It says write an expression using T and Q that represents the total number of sides in your envelope. So let's think about this. If you have 3 triangles, how many sides do you have? Well, each triangle has 3 sides, so 3 times 3 is 9. What if you had 5 triangles? 5 times 3 is 15. What if you had 10 triangles? 10 times 3 is 30. So notice that you're multiplying by 3 every time because there's 3 total sides. Well, if we don't know how many triangles, we represent that with a T. So 3 times T would represent the total sides of the triangles. Now we're going to add that to how many quadrilaterals you have. Well, a quadrilateral, think about that. Quad means 4, means that it has 4 sides. So if you have 3 quadrilaterals, you would have 12 sides. If you have 4 quadrilaterals, you would have 16 sides. I'm getting that once again by multiplying 4 times however many quadrilaterals you have. So this would be our expression for the total number of triangles or sides for triangles and quadrilaterals. Now, part B says you and your partner have the same number of triangles and quadrilaterals in your envelopes. Write an expression that represents the total number of sides that you have together. So we have 3T plus 4Q. That's how many you had. But there's 2 people, so we can just multiply that by 2. Now, is there another expression that we could write instead of just multiplying this by 2? Think about this. When you have a number outside of a set of parentheses, that's the distributive property. So we really just have 6T by multiplying 2 times 3T, and 2 times 4Q is 8Q. So this expression, the second one that I wrote, is the same as the first one that I wrote. All right, part C, what if every envelope in the class contains the same number of triangles and quadrilaterals? How many would that be? Well, if the envelope is 3T plus 4Q, and there are 22 kids in the class, then we would multiply this by 22. If there were 24 kids in the class, you would multiply it by 24. Take a second and count how many people are in this class right now and put that number in front of the parentheses. All right. That's kind of like what we did yesterday. So now let's go into adding those types of expressions. So it says rewrite 5x plus 3x and 5x minus 3x by combining like terms. So we're going to write the original expressions and then expand it using addition. So 5x plus 3x. All right, let's start with that one. We're going to expand that. Now 5x's, what does that look like? 5x's is literally 5 x's added together. That would be 5x. Now, if you're going to add 3 more x's, what would your total be? You have 5 x's, you add 3 x's, and you get 8 x's. All right, how about 5x minus 3x? Let's do that. Okay, so say we start off with 5 x's. Oops. And we want to get rid of 3 of them. 1, 2, 3. What are you left with? You have 2 x's left. Now, how do we do that without expanding everything? Well, look at what we did. 5x plus 3x. Well, what's 5 plus 3? That gives us 8. These numbers right here in front of the x's have a name. Those are called the coefficients. That is the number in front of the x. Sometimes it could be y, whatever variable you have. So when you're adding, we call these like terms. They both have x's. 5x plus 3x gives us 8x. You're just going to add the coefficients. Now, 5x minus 3x, we really don't like subtraction. We've been talking about this. So whenever we have subtraction, we have to get rid of it and change it to adding. So if I do that, 5x plus negative 3x, change it to adding its opposite. Follow your rules for adding coefficients. 5 plus negative 3 gives us 2. So you can do that without expanding like we just did here. So let's look at the next one. It says find the sum. Sum means we're adding, and this is what we're adding, these two things right here. So let's write that, 2x plus 1, and we're adding that to 5x. Now, like I mentioned before, you can only add like terms. Let's write that down, like terms. Like terms are terms with the same variable. You cannot add two terms that have different variables. So these parentheses, when you're adding, actually mean nothing, and you can get rid of them if they're too distracting. So then it would look like this. No parentheses because you're adding. So we're going to add like terms, meaning we're going to add the numbers with the x's. So I'm going to circle those two terms, 5x and 2x. I'm going to write them next to each other. Now, 1 is not like 5x or 2x because it does not have an x. So I'm going to write that last. All right, so let's add. 2x's plus 5x's is 7x's plus 1. And this right here is actually my answer because this has an x, this doesn't. So I can't go any further. All right, so let's practice this again. This time we're going to add this and this. So let's write that. We have negative 3a plus 2. We're going to add 5a minus 3. I know I'm adding because it says sum. Once again, when you're adding, the parentheses don't mean anything, so I'm going to get rid of them so they're not confusing. Now, the first thing we got to do is get rid of this subtraction sign. We don't like subtraction, so we're going to change it to adding its opposite. So I'm going to change it to adding negative 3. All right, so let's see our like terms. We have this term right here. I'm going to circle it. That has an A. So think about what other term has an A. Put a circle around it. Those are like terms. 2 is not like that. It does not have an A. So I'm going to use a different shape. I'm going to use a square. The negative 3 is like the 2 because they both are just numbers. So I'm going to put a square around both of those. Now, before I'm going to add, I'm going to take the circles and I'm going to write them next to each other. And I'm going to take the squares and I'm going to write them next to each other because those are the ones I'm adding. So this was a circle, circle, square, square. So let's add. Negative 3 plus 5. Opposite signs, you're going to subtract. 5 minus 3 is 2. 5 is bigger. 5 is positive. Don't forget to keep the A. 2 plus negative 3. Opposite signs, subtract. 3 is bigger. 3 is negative. Now that's my answer. 1 has an A, 1 does not, so I can't go any further. So it's 2a plus negative 1. Now, 2a plus negative 1 is the same thing as 2a minus 1. Because if I did leave change, I would add the opposite. So those actually are the same answer, and it doesn't matter to me how you write it. All right, so before we move on, let's take down the steps that we followed to adding these like terms. So step 1 is we're going to drop the parentheses. Step 2 is that we are going to change all subtraction to adding the opposite. Step 3 is going to be to combine like terms. We use circles, we use squares, but that's your steps, and we want to label that. That's for adding. Now, let me give you another method to use that you may or may not like better, and it's totally up to you what you use, but sometimes this is done vertically. What we did was horizontal, so what we're going to do next is vertical. Now, notice we're adding. We're adding this expression plus this expression. Take a second to write the first expression on your paper. And then right underneath that, we're going to add. So you're going to line up your like terms. So this is a 2a, put it under the 5a. Minus 4b, put it under the 3b. Plus 13c, put it under the 6c. Now, before I go, it says that we're going to change all subtraction to adding its opposite. So this I'm going to change to adding a negative 6. I'm going to change this one to adding a negative 4b. So let's add. My like terms are now right in a row. So 5a plus 2a is 7a. 3b plus negative 4b, opposite signs mean I'm going to subtract. So 4 minus 3 is 1b. 4 is bigger and 4 is negative. Same thing here, negative 6 plus 13, opposite signs subtract. So I get 7c. 13 is bigger, 13 is positive. So right here is my answer. I can't go any further because I have A, B, C, and none of them are like terms. This is the same as what we did up here, just this was horizontal and this was vertical lined up, where you don't have to do the circles and the squares. It's totally up to you how you want to do it. Now let me show you the vertical method again, just so we get more practice. So we're going to take this first expression and rewrite it. And we're adding. Now the second expression, make sure you line them up. So the 5x goes under the 2x. The 2 goes under the 4. Doesn't have a y, so we don't put it there. We just leave a space there. Let's change all of our subtraction now. So this becomes adding a negative 4. And now let's add. 2x plus 5x is 7x. This would be like adding 0. So 3y plus 0 is still 3y. Negative 4 plus 2, opposite signs you're going to subtract. 4 is bigger, 4 is negative. Now you can write it as minus 2. That's the same thing as adding a negative 2. It doesn't matter what way you put it. Okay? All right, so that was adding. Let's go into multiplication. When we are multiplying, we're finding products. Means we're going to multiply the two numbers together. So in this case, it would be 2x times 3. Now that could be read as 2x 3 times, okay? So you would be adding 2x 3 times, because remember, multiplying is the same thing as repeated addition. Well, 2x's plus 2x's plus 2x's gives us 6x. Now, just like before, we don't always have to expand. There is a way to do this without expanding. Let's look at 4a. When you're doing this and you're multiplying, you can multiply in any order. So if we want to multiply the numbers first, then the x, we could do that. So 3 times 2 gives us 6. Multiplied by x gives us 6x. Kind of like up here. 2 times 3 is 6. Just keep the x. Seems a little bit easier than expanding it every time. Let's do that again. Multiply the two numbers together, then by y. So 4 times 5 is 20. Y. Multiply the two numbers together first, which is 8, and then by z. Now, this one we have a plus sign, so we are going to work on these two terms separately. So first, let's do 3 times 2, then multiply by x, which is 6x. Then we're going to do 4 times 5, then multiply by y, which is 20y. Now, think about what we learned with adding. When you have an x and a y, you cannot combine them. They're not like terms. So this right here is my answer. Let's do that again. So multiply the numbers first. 3 times 2 times x, 4 times 5 times y, and 4 times 2 times z. So 3 times 2 is 6. 4 times 5 is 20. 4 times 2 is 8. We have an x, we have a y, we have a z. None of them are like terms. So that's my answer. Now, that's the end of the lesson. You are going to work on the problem set, and we will go over that in class tomorrow. If you need to go back and check and re-listen to any parts of this lesson, feel free to do that. This is a very difficult lesson, and I want to make sure that you are very clear on how to add and multiply. Have a great day.